Hello, my name is John Cook and I'm the European Technical Services Director for Genus ABS. And today I'd like to talk a little bit about how we should use a silage report to assess the silage that we are offering to our cows. A silage assessment or a silage analysis contains really two important pieces of information that we can see from the report. The first is the nutritional characteristics of the feed with regard to energy, protein and so on, and this allows us to assess the quantities of each nutrient consumed by the animal provided this feed is actually eaten. The fermentation characteristics of the feed are indicated by the pH, the amount of lactic acid, the amount of volatile fatty acids and so on, which provides information regarding the quality of the fermentation of the crop. The quality of fermentation critically influences its palatability and intake potential, and also influences factors such as the rate of secondary fermentation once the crop is fed out. It is possible to have poorly fermented silage with reasonable protein and energy content, provided these nutrients were high in the original crop. And likewise, a well-fermented crop does not guarantee a high nutritive value. A well-fermented crop is, however, likely to be eaten in greater quantities by the animal, as its palatability and intake potential will be higher. Higher forage intakes will also prevent the likelihood of the occurrence of clinical or subclinical acidosis, often known as SARA. The first part of a silage analysis report tells us mostly about the nutritional characteristics of the feed and the likely amounts of each nutrient supplied to the animal provided the silage is actually consumed. This information is necessary to enable us to estimate how much of each nutrient the actual animal receives when we are putting together balanced rations for cows. This is a chemical analysis of the feed and tells us very little about how the silage will interact with the animal, both in terms of palatability and also how it will affect or influence rumen function. The pH indicates the end acidity of the silage and hence its stability, but it does not prove that the process of ensilation has been successful. Whilst a pH of around 4 normally indicates good stability in fermentation of the silage, more information on the acid profile is required to determine whether the ensiling process has been truly successful. The fermentation characteristics of the silage are shown in the final part on the analysis report. This is a more recent addition to the information supplied as part of the analysis and was developed as part of the Feed into Milk project in the early 2000s and is an attempt to describe and predict how well the silage will be eaten by the animal and its likely impact on rumen function. It represents an attempt to predict the responses of the animal to this feed. Volatile fatty acids on this report are the volatile fatty acids acetic acid, propionic acid and butyric acid that are produced during secondary fermentation and indicate spoilage and reduced palatability of the silage. Levels of more than 40 grams per kilogram indicate high protein and nutrient losses and poor intakes. Good silages have levels below 20 grams per kilogram. If volatile fatty acid levels are high, it usually indicates that a degree of secondary fermentation has taken place. The middle part of a silage analysis report is an attempt to describe how rapidly the protein present in the silage will be broken down in the rumen and how quickly it will be available to the rumen microbes and how it can be used in detailed ration formulation to allow software packages to attempt to match the speed of protein breakdown in the rumen to energy supply from fermentable carbohydrates. There should not be any problems associated with feeding silages of acceptable levels of volatile fatty acids, lactic acids, intake values, PAL and RSV values unless other dietary components are chosen without giving due consideration to rumen health and the risk of acidosis.